Thank you everyone for joining us. This is a continuation of our session that we had 2 weeks back, where we discussed about the anatomy of a data product, the non-functional requirements. Rajesh would do a quick recap of what he covered, but also walk you through a deep dive of example data products. And I think we got to make it very interactive. This term of data products did get a mention in the Gartner Summit that just got completed this week. And there was a lot of buzz generally in the market around, hey, data products, what's the next big thing and all of that. So with that in the equation, right? So let me hand it over to Rajesh. Most of you know him. Rajesh, why don't you start with a quick...
I just want to quickly make sure that you guys are able to see me.
Yes, we can see cool. As well as see your screen as well.
It's moving.
Okay.
Are you able to see now?
Yes, we can.
Okay, then.
Yeah, I know you're logged in from 2 places, so that's totally fine. Rajesh, why don't you quickly start with a quick round of introduction and then we jump straight into the session.
Sure. This is Rajesh Parikh. I'm the founder of Cynepia Technologies. We are a data products platform company. Fundamentally, over years of building the data systems, we've realized that one of the core missing pieces has been the industrial grade data products, which is really what we've been missing with the infrastructure that we have created over the last decade. And data products, therefore, is an idea that rightly fits in the ecosystem where we want to accelerate the consumer perspective or the experience, enhance the experience, and make sure that the products are that we build out of the data are consumption worthy and reduces the friction for consumption, right? So that's fundamentally where all the roots start from. The need itself hasn't been met, even though we have tremendously employed all the infra that we could, right? On the in the last session, we actually went through some of the details of why we need it, what is a data product. We briefly also covered the categories of data products, and then also just to recollect the anatomy of the domain products.
Rajesh, would it be possible for you to quickly highlight the different types of data products?
Yes, I'm about to do that. And but before that, just want to make sure that, I mean, just a quick call on how many of the folks here have been in the data engineering domain versus the data science domain. If anybody wants to, I mean, we can just open up the conversation from there.
Yeah, can somebody unmute the line and we go from there?
Right, and is data products very new, or you've heard it before beyond me, or how is this whole thing shaping up on your mind?
Yeah, Shri, you want to unmute your line and speak? What are you doing? ETL, ELT, is data products a new thing? Is your company doing that, evaluating that today?
Yeah, hi Ashwin, thank you. So hi Rajesh.
Hi Shri.
Yeah, so I'm into data engineering team now. So we are extracting data from different source systems. It might be some connecting to databases and APIs integration. Then we are transforming, then loading into the database, which is currently Snowflake database, what we are doing. And then the analytics team is consuming that reports, the data basically for their reporting purpose. So this overview of what we as a data engineering team basically more focused on transforming the data and getting from different source systems, generating some kind of a golden records for the reporting team. Yeah, thank you.
Just a quick question. What's been your experience on the quality? I mean, as the customer perceives through this funnel that you've already created, are people feeling that things are giving them repeatable experience? Are they breaking up? How are things on that count?
Yeah, so as the time passes, like there are some discrepancies on the accountability of data, some challenges basically. So that we usually face as the team is growing and team members are changing, right? There might be some existing things which are causing some discrepancies on data flow when the data is flowing from different systems with different kind of technologies. So when we have kind of a limited knowledge with our scope of work, right? So during that, these kind of issues we are facing. Yeah.
Sure. So I think there's also, I mean, I think we should keep this interactive to just to make sure that we also appreciate the details as we are seeing and how things are on the ground. Where is the overlap and where is no overlap, right? So let's continue on the journey. But fundamentally, if you guys recollect last time, what we discussed is a data product essentially is about starting with the business need and then flowing back to the production process and finally the infra, which kind of flips the way we think today. Today we start with the infra, then get all the data flowing into that infra, and then we start building the data, the star schemas, and then the data marts and so on and so forth, right?
So yeah, sorry to you, Rajesh. Is it like basically you are talking we are just reverse engineering the process here?
No, it's not reverse engineering, but it's basically reverse prioritizing. If you think about it, I mean, let's say and we took the example of cereals. Let's say you went to the market to buy today. You really don't worry about what is, I mean, you're picking the Kellogg cereals. You don't necessarily worry about how that experience is going to be every single time that you buy, correct? So fundamentally, the reverse engineering would not be the right word, but basically how we emphasize on what we are prioritizing. We are prioritizing the customer experience first, and then everything else that we need to do, infra, product building, everything flows from there, right? What we have done over the last decade is we have focused on the infra first. And then we've learned how well the data, how can we actually scale the data. We've learned how can we compute queries or relational queries on this data infrastructure, ask questions of it, right? That is how we have flown. We first built the infra, then we've actually scaled it up, and then we are learning to ask the questions on it. And then we're presenting it to the dashboard, right? So this is how the evolution has happened over years. And that's why we have what we have. But as we move into the next journey of this data, and especially the folks who are producing, they will have to start worrying about how do we scale the number of products that we build at a speed that we can, right? That is one part. How do we make sure that each of these products emphasize on the repeatable customer experience? Remember, we kept saying that a customer grade experience is what the customer wants to consume, and that has to be trustworthy, repeatable all the time, right? Now, if let's say you consume the Kellogg's cornflakes or cereals or any kind of cereals, but what you bought this time versus what you bought the next time, if there is a difference of experience, then there is no brand loyalty, there is no product out there, right? At the end of the day, it's a very low value product because you could have bought that flakes in the open market and yet you go and buy Kellogg's. And the difference simply being the fact that it gives you that repeatable experience, that trust that you're always wanting to consume, correct? So, I mean, just taking another analogy here, if you start thinking about it, we built all the plumbing lines that we needed, right? The ETLs of the world, we made the data flow into the warehouses. We did all of that. And eventually, when you opened the tap, you got the water, which is not consumable, right? Or if it's consumable, it's not necessarily consumable every single time that I want to drink, right? Would you then drink that water, or would you actually go order a mineral water bottle, right? So that's kind of where we are today. We've become plumbers in a way. We're not thinking from the value perspective. Even a mineral water bottle could actually enhance the value perception, despite the fact that there's no plumbing involved there, right? And I think that's really where the mindset has to flip, or in terms of what do we expect out of data products. That is one. Two, one of the other things is which we as data community have probably not done a good job is thinking from the domain point of view. Think about it this way. We've been building all the star schemas that we want. And at the end of the day, when you go to the business user, what does he really consume? He wants to know the metric. So we added a layer on top, which is the data mart, or let's say the dimensions and the metrics in your BI dashboard to make that happen. So what is actually being consumed is the metric, not necessarily the data that you're storing in the warehouse. Yes, the metrics are derived from the data, but think about it where the consumption really lies, and how are these numbers that are being dished out on the dashboards accurate and trustworthy every single time, right? And that's been a challenge fundamentally. Sometimes the data is stale, sometimes the source system has inaccurate data that flows all the way to the dashboard, so on and so forth. Right. So when you look at all of this, what it really comes about is we've got the plumbing lines going, we've got the data flowing, and yet we haven't been able to get the trust and the quality perception that we truly deserve all the work that we've done. Right. So that is where I'm going to stop. This is one sort of what we call the modern data stack, or generally the warehouse centric design. But if you actually go forward and look at the other data products, which are on the ML side or the
Rajesh, your screen is not moving if you're changing that.
My screen is not moving because I have not flipped it. But
okay, got it.
Is it moving? I was just coming back to the topic. Fundamentally, this is the same story that repeats also on the ML side. We've got the fragmented tooling all over the place, and we haven't been able to ensure that the model quality that it was trained on is the same quality that you get version on version, revision on revision, so on and so forth. So what data products is doing at a first thing is it's putting the customer at the center. The second thing it's saying is infra last. The second is the domain. You're basically saying data, yes, domain important, and then the access, the way the users would access is equally important. And the only difference is whether they might access via SQL or my API or might consume via a user interface, right? So if you actually look at the next set of slides that we're going to talk through, each of these categories of products that we're building actually are not very different, even though we have parallel stacks today, and each of these are built around, let's say, the BI stack or the ML stack or the deep learning stack, so on and so forth, right? So we start with the series of questions. This could be descriptive, this could be diagnostics, this could be predictive questions in our minds. And eventually you want to get the answers of each of them without having to start thinking about, hey, is this an ML question? Is this a BI question? So on and so forth. But I'll pause here and I'll just get back to the slides. Last time we did discuss and we defined 5 categories of products. When we come to data products, the first and the most important one is the domain data models. We've discussed briefly. We will just revisit that topic a little bit again. Then we talked about the metric or the dashboard data product. Then we have the advanced analytics product, and then the machine learning product, and the final one, which is kind of more complex, which is the multi-model data product, where essentially you could potentially be looking at an app where you're asking a predictive question, a descriptive question, or let's say a chain of questions without having to worry about how you are navigating on a given topic, right? So that could be a multi-model data product, right? So these are the 5 categories of products, and eventually, if we start thinking that the data world is going to transition into. Interestingly, today I read an article from Tacton, which is again a feature store company, and they've started talking about data products, which is pretty interesting because Tacton essentially comes from the Uber. The founders come from the ex-Uber background, and even they feel the need to talk about data products, right? And that kind of tells you that we're probably at the transition phase where this is probably going to be the new norm in the next 2 to 4 years, most likely, right? So the right time for us to talk about this topic as well, right? So I'm getting to the next slide. We had covered this last time, but the most important thing, like we said earlier, is that we're good at building, let's say, the star schemas where we're talking about the fact tables and the dimension tables. As you come to the data products world, the domain becomes important. So we model, while we may still model the star schema, but most important thing is the representation, the conceptual or logical representation that you have has to mimic the specific business object, a specific domain, a specific function, and should not look like a table, even though it could be a table or a set of tables, right? Here, what we're basically saying is the logical model that you're building should essentially define the entities and the relation attributes as you see in the real world. For example, the entities could be orders, the products, so on and so forth, which may look like your dimensions, but the attributes, the naming, the language, all of that we use should be more consumer friendly. Let's say, and we took an example of finance, where let's say if you have two attributes, cash flow and a discounted cash flow. In a table world, we don't really care about it, but a finance professional would really care about the difference between the two. And therefore, how we name, how we model these logical objects have to be more user-friendly to reduce the friction to consumption, right? So while a lot of us are aligned to star schema, fundamentally star schema's origin is to optimize or normalize for the space and the storage, right? Whereas the logical model that we're doing in the domain modeling is more optimized from the end customer's standpoint. At this point, I have a question for folks. How many of you actually use star schema today in your warehouse modeling? And how many don't? Or is there anybody who doesn't?
I think almost everyone would say yes, if I'm not wrong.
Anybody would say no?
Star schema? Anyone saying no? Unmute your line. Or saying yes? You all use star schema? Okay, anybody not using star schema, but let's say using a data vault approach or alternate approaches?
Okay. So we come back to what we've been talking about, which is the domain product. We touched it briefly. Now let's look at the anatomy, since this discussion is about the anatomy of a domain product. And by the way, there is today while I was preparing for some of the examples, I ended up on one of the Airbnb's metric store example. I think they call it Minerva, and it was very fascinating to see that although they were not calling it a data product, a lot of what I have written here is something that they have tried to do when they build a metric store, right? So it's not like we don't know how to do it, or this is the first time we are trying to do it. It's something that people have tried. It's just that now what we're saying is, while it may have been tried in one instance, it needs to be for every single data product that we build, right? So let's look at the anatomy. I have just put the brief here, but let's look at the actual diagram. As you see, the most fundamental thing, right, in any domain product is it is domain specific. So you're actually bringing up the entities. Let's say if you're thinking about the marketing domain, you're probably bringing up the customer entity, the campaigns, the emails, so on and so forth. So these are your entities or the domain models around these. So you're basically bringing in a bunch of data sources together. You probably have a connectors library that's available to you. And what you're doing at that point is you're probably storing that data in a version data store or a warehouse, whatever might be applicable there. Warehouses obviously are the norm today, but if you're looking at versioning and all that, you might possibly want to store it in an object store, so on and so forth. So you get that, then you have the input validation or a checker system, what we call, right? Every single of these domain models need to have this, because without stopping the bad data from flowing ahead, you're not going to be able to tame the problem of repeatable experience, right? So what you're really doing at this point is you're basically saying, hey, is there an agreement that I have with the sources? If I do that, I'm going to actually validate for those agreements. Even if I don't have, I will validate for what I believe is a good reference data, and you will apply your input checking system here. Now, if it does meet your expectation, you flow further into the domain model building. Now, this model, like we discussed, could be your business model that you're building, like your customer from a marketing, as marketing sees, or the product as marketing sees, so on and so forth. If you're building for a marketing domain, for example, right? And potentially you could also build the metrics at this point if you like, or you may probably let it flow to the next version. But once you have those tables, you are actually then again checking whether these tables are as per what I promised, right? Does it meet the agreement that I am promising to the downstream consumers of this particular product? If it doesn't, then you're actually again going back and basically raising the alarm so that somebody looks at it. In cases where you can actually clean it up, or you can, for example, there a simple classical case. Let's say I have some missing data, or I have data that's come in late, and I know that that one of the data set is not refreshed. Now you could potentially go and refresh it at this point, rather without avoiding without asking for the human intervention, and it can be actually fed in the logic, right? So if you can clean it, if you can actually defend against a potential error, then you should automate that. And that's how the product experience can be preserved without somebody having to get interrupted.
Yeah, sure. Rajesh, interrupting you here. Now, isn't this something that we do today in your modern data architecture or reference architectures? Given a data source, we use an ETL or an EL tool.
I think it's a valid point. I have the next slide actually on the same thing, and I'm going to go through it. But fundamentally, a lot of these ideas are actually not new. If you start thinking about it, I mean, just flipping back in time, why did we really feel the need for the metric store? By the way, how many here are actually using metric store or are aware of metric store?
Yeah, I think, can somebody new and mute the line?
Anybody's using metric store here?
Yeah, let me read out Pallavi, Michael, Jeremy, like you want to unmute the line. Are you using metric store? No, yes.
Yeah, hello. Yeah, we don't really use a metric store. We just write queries on top of our tables.
How many use input validation?
That would be typical data quality rules in our
world. No, in the line of the flow or afterthought?
In the line of the flow, we call it as DQ rules. When you're moving, extracting data, you check for schema validations and all that. I think most of them would do. I'm not sure if somebody is not doing it already. Apurv or Mike, I see Parikh, Sunil, like we do that today, right? In reference architectures.
How many do output validation?
Yeah, I shouldn't be answering that. So can somebody else?
So
hello. Yeah, let's wait for an answer.
Sure. So my point to you is this is not something that's radical. It's just that we have not been consistently and repeatably doing it, in my opinion, right? When somebody like Airbnb puts it out, it becomes like a dramatic thing that, hey, everybody should be doing. But the reality is it's just something that the consumers actually want. You don't want them to serve something which is not accurate, right? So that's just a mindset change. You start with the consumer and then flow from there, right? So going back to it, so once you have a consumable product, and here we're saying the domain model is the product, right? You basically publish it to the marketplace. In this case, unlike the catalog, you're basically saying that there's a push mechanism. There is a new product version and the consumer should know about it with all the documentation, telemetry, summary, that the customer should know about what this product or this version of the product stands for, right? Likewise, as you see in this flow, at every step, there is telemetry. Right from your connection or the data pull to your input agreements, validations to the product, and also all the way to the agreements, right? So at every step, you're generating logs, audit logs, telemetry. So if there is a site reliability engineer or a data reliability engineer, he can actually debug it while he's at it, while he's looking at the observability dashboard, all of that. Again, here, observability is a push mechanism, then a pull mechanism, right? So the product itself decides what does it need, or the product engineer decides what is that is important for this product to be serviceable in the first place. So I'm moving ahead, and this is the slide that we actually looked at it last time as well. And Ashwin, back to your question, isn't this what we're doing today?
Yeah.
The reality of this whole thing is, as you see here, in this particular slide, what has happened?
Is there a question from someone?
Yeah.
Yes, Raj. So can we go back to the previous slide, Raj?
Yeah.
Yeah. So what is a typical case is, yes, everybody understands that the observability is important and validation, everything is important, but two hindrances takes place. One is time to go to production, one.
Yeah.
And the next one is ROI. When I say ROI, the cost involved to implement the infra, and also whether the customers will really need it or not. So both.
Look, let's look at it this way. Even the most basic product that you're consuming today, let's say water, which is coming through the plumbing line, right? We don't even think about, there are a lot of derivative products of water. Let's say your Coke, your Pepsi, your tea, all of that, right? If the water goes wrong, every derivative product also goes wrong, right? What I'm
exactly. What to say? Maybe we can split into two different things. One is to serve for the application, and other layer is mostly for the reports and analytics layer of a product.
Yeah.
In both the cases, such things would do. And I totally agree that all this observability and all those things really make sense, 100% makes sense for the that serves for the application. Okay, so let's consider Salesforce. It's for the application, it is most important. But within Salesforce, there would be some reports or analytics module. For that, from the operational DB, the data would be migrated into some analytics DB, like Snowflake or some other data warehouse system. So in that case, first, making the application to run is the main goal, and then only all these artifacts come into picture.
No, absolutely. No, that's probably I am fully with you. My point to you is the application running itself. So there are two questions that you asked. One is the ROI. For low value data products, is there an ROI to do all this work? Right? That's the first question, really.
Yes.
The way I think about this problem is, it's going to become so easy to build this as we get into the next phase. That question, you are going to be churning out data products at a much faster pace than you churn out the SQL stored procedures today, right? So it's all about how we are going to be supported by these frameworks, which are going to make this so. By the way, expectations as a library is all out there today. I'm talking about the Great Expectation or Soda or one of them, right? The reality is it's hard. Because it is out of demand. It is not in the product development. Let's put it this way: the work that a data engineer or an analytic engineer does today, right? But if you actually look at it closely, it probably is just a YAML that you're writing in most cases to define what validations you want to do. There's hardly much work there, in a way. If you really know what you're doing, you can actually get it up and running in literally no time, right? So the question of low value versus, or let's say the ROI, is fundamentally about what tools and what mechanisms and what trainings do we have that it can even work for a low value data product. All of this infra that we're talking about.
Understand. So while it's been a conversation, few data architects literally take this decision knowingly. Yes, this is important, but we can't accommodate as of now. I could see such.
They could. Look, they could, but like I keep saying, if you one of the fundamental things that we've defined during the definition is, if it doesn't serve the repeatable experience, it's not a product. In which case, you're back to the old model where you're serving a report which could go wrong. You get what I'm saying? See, the qualification for it to be a data product is, at minimum, the trust and repeatability needs to be preserved.
Okay, understood.
Right. So, I mean, we are living today as well without them. So it's not like we're not, right? It's just that is the consumer getting what we're supposed to be giving him, which is the experience? See, I mean, again, things in life are, I mean, yesterday I was at a restaurant, and let's say if you've ordered something at the restaurant, you're not just consuming, let's say, the Coke or whatever, you're consuming the overall experience, right? As humans, we're not very good at consuming tables. We're consuming the outputs. At the end of the day, the experience is tied to how I feel about how it's helping my job. I don't really care whether it's a table or an app or a web page or something else, right? Think from end consumer point of view, and you will probably get a feel that he really doesn't care about even what I've written on the slide. He simply cares about what experience will come out of it at the end of it.
Understood. Get it.
Right now, coming back to this particular slide, now this is how we've been doing things today. And as years passed and we realized there are new requirements. For instance, if you look at it, original stack was pretty simply the ETL plus the warehouse and a BI, right? And over time, we have added, let's say, DBT, what is more about adding the testing phase and so on and so forth to how we write the logic, right? Which is again back to quality. And then we realize that is not sufficient. We need more input validation. We need observability. We need governance. We need catalog. We need lineage, so on and so forth. So what you're seeing in this diagram, and then finally the data mart and the BI, where the finals, BI is the serving layer in this case, if you look at the top. And then there are these applications where you see the reverse ETL to the right center, and then the other applications. And then bottom of it, you have the third set of use cases, which are more around ML models and so on and so forth. Now, what has happened over time is all of these small nodes that you're seeing connected in a graph format are the actual outputs that we're churning out today, right? So for instance, each of those nodes could be a table, which in turn is inherited by another table to another table to another table. So what has happened is these convoluted logic where or the interdependent destiny has taken over the final experience, right? These graphs or DAGs of stored procedures and tables have over a period of time become extremely complex, right? And if one breaks, you are almost sure that everything downstream is going to break, right? So let's say if you broke one of those models, which which somebody had built, a data scientist had built an ML model on, then that's going to break all the predictions that are going to go out there, which are dependent on that model, and you really don't know why that model broke in the first place. So you would probably have to hunt and see, hey, did the source system change, right? And this whole process of trying to trace where the problem lies is extremely costly, especially when something is in production. And that's really where all of these dots that we have, or the nodes we have in the graph, are not necessarily behaving like the products that we have built. They're simply logic and tables which cannot guarantee anything more than the fact that they were tested for a certain scenario and now they're not holding up, right? So if you think of each of those nodes as products of today, then I don't think even a data engineer will stand behind and say, hey, this is my work and I guarantee it. Because there's nothing that one has done to really make sure that those guarantees hold. Would you agree with me on that?
Rajesh, I'm going to put you on a spot and probably ask you to answer that.
I selected 2 rounds. 12 plus 12, 24. Okay.
I'm getting Venkat. Probably I think there was a crosstalk. Dinesh, do you agree with that or? Okay, Ganesh went on mute, probably on mute if you're speaking, Ganesh. Yeah, so Raj, one point I would like to add. I think great points added so far, but I think the challenge was occurring because we started with the information age where all we needed was to collect data, and then we added wrappers on top of it and added wrappers on top of it, and that caused the chaos, right? I think is it a right time for us to
No, absolutely, because we know each and every piece of the problem space. See, look, the great expectation. Just take an example of the libraries that are coming up and becoming popular. Great expectation, metric store. You can talk about contracts. All of these are coming up because of something that is being felt, right? We talk about observability, tracing, lineage. Everything is basically. And what really has happened is we have associated all of these to the infrastructure attribute. And we have added layers and layers of infrastructure and made it further complex. In reality, each of these are product attributes. Unless the product itself ensures that it is built for the consumer grade quality or whatever the quality was promised, none of these infrastructure are actually going to be helpful. Right? Can I move further? Right?
Yes, Rajesh, yes.
We did, just going to go back to this one slide. We looked at the L1 product, which is the domain model. There is L2, L3, L4. The way we've defined it is I've taken 4 use cases, which will give you a sort of a quick flavor of the first 4. And also give you the flavor of what we call, and last time I did mention this to you, that one of the big thing about data products is to explode the number of derived products that the data product engineers can actually build, right? The sky's the limit, and in terms of the number of products, the valuable products that they can monetize internally, externally, that they can build. And therefore, it's only waiting. And I took the example of the plastic industry, which takes crude as, or let's say the crude derivatives as the input, and then churns out innumerous low value to high value product, right? And I think that is, data is also a similar raw material. You really can take out innumerous number of products and at a very rapid pace, right? So what we've done here is we've just first categorized it, and we've taken some examples of how would these products look like if we were to, and since it's a topic of anatomy, we've taken one in each of these buckets except L5, just to get your brains rolling on. A couple of them I've taken are not necessarily analytics, but more around operations. But just to give you a flavor of what you can do with some of these L2, L3, L4 kind of products. Right, so we looked at the domain. Now we're getting into what I call the recon. Another use case, reconciliation data product, very common use case in many of the financials, very important in finance as a department. A lot of them have this process where they would want to do recon between balance sheet and income statement, the month-end reconciliation, the end-of-day reconciliation, the sub-ledger to ledger reconciliation, the data reconciliation. By the way, data reconciliation is actually not a finance use case. It's more of migration. When you're migrating from system 1 to system 2, you're always unsure if some columns or some records have gone missing, all of that, right? That's another one. Then invoice to bank payment reconciliation. So there are many use cases around just a simple activity called reconciliation. And really, what is this activity? It's just a process of comparing transactions and activities to resolve if there is, and identify if there's any discrepancy that might have occurred between 2 sets of data sets or between 2 sets of systems, and so on and so forth, right? Now, if this goes unnoticed, it could have serious issues with accuracy or insights, or issue with customer service as well, right? So let's look at what would you do in a recon product. Typical strategies that you would have is you would probably do a field by field comparison. You probably do a quantity by quantity comparison, or an amount by amount comparison. You probably do a regex based matches, row counts, timing based matches, key mapping, probabilistic matches, whatever, right? These are various strategies that you might use to build a recon product, right? Now let's look at what would a system look like if we were to look at recon as a product, right? The first part is pretty simple. Same ingestion system where you're basically connecting multiple systems, assuming they're coming from different systems. If they're coming from the same systems, you're potentially pulling different tables from those systems. You have so all the green blocks there you see are the data product development framework. You're not really building them. You're using them to get the pipeline done. I will talk a little bit more about this since it's an anatomic topic. I've not spoken about the framework piece of it, or I'm not speaking about the framework piece of it, but fundamentally all of those green dots are available to you. You're not really building them. You have the ingestion pipeline, the standard one, and then you have that pipeline that you see in the middle, which I call the reconciliation pipeline. This again uses some libraries that you see above, which is, let's say, the strategies, the recon processors that you saw in the previous slide could be available to you as a library, potentially. And what you're really doing is you're pre-processing the data, you are basically applying the comparison algorithm, generating the outputs, post-processing it, and then storing the output in a virtualized data store, right? This part of the let's say the process is pretty familiar to most of you because it looks like a typical pipeline, just that the operators may be different so far, right? Now, what would happen is a recon product could potentially be served through a user interface, right? It may not necessarily be served through a dashboard or a BI dashboard. So you obviously need a user interface here, and you would potentially have the user interface designer or potentially a YAML-based user interface. There are products like Streamlit if you're doing a micro user interface, so on and so forth. And then this particular user interface eventually gets deployed as a product through the product development environment that, again, is part of the product development framework, right? So the only piece of the puzzle that you've actually written here is you've written the ingestion pipeline, you've written the recon pipeline, and then maybe somebody has built the user interface through a drag and drop or something similar kind of interface, and you've got the product out pretty much with that amount of effort.
Correct. Rajesh, one question, again, asking on behalf of the data engineers here on the call. How different is it from what we're doing today when we're doing recon today, right? So we typically do have an ETL product or it could be a code also. Most of the recon is done at code level also because you're comparing two tables, comparing outputs, and performing a certain set of repeated logic.
Absolutely. So I think, look, there are 2-3 things that I have seen personally. One is that what many of these recon teams do is download it in Excel, and they would have probably templated in Excel and then they generate the output and send it out. That is one kind of a recon. The second essentially is a sort of a vertical app that they would have procured, right? But the way you want to think about, Ashwin, this is recon. It's not one use case. Actually, there are many use cases there, right? And today, the organizations don't have the number of products that you need for each of these use cases. They're low value use cases. Like I said, they're L2 or level 2, but they have a lot of repeatability, repeatable need, essentially, or let's say it's a daily need in many ways, right? Now, this kind of a simple product today is not necessarily there with most of the organization, in my opinion. So a lot of this recon work happens in Excel today. Some of them do have products, but they are usually sourced. They're not typical ones that the data teams build. Any comments on that, or anybody has a different opinion here?
Yeah, anybody wants to unmute the line, or probably we'll see another data product.
Yeah.
Right. So that the RevOps one. That's.
So this is just one slide that I put in. I mean, we were here on this slide, and this is how the architecture looked like in the current case. And what really happens when you come into the data products centric world, this is how it really looks, where you have the source systems and you have a bunch of products which are domain specific. Each of these products are generating output that could be going to a data lake, a lake house, or a warehouse, whatever, right? And then these domains themselves essentially share their output with the other domains, right? So fundamentally, it's I wouldn't say decentralization. Decentralization is more around the product building. It could still be a central team building it, but basically building domain-specific products in this particular case. On the top, what you see is really the data product marketplace. This is where the discovery actually happens. And then, of course, you would have an observability where you basically have the SREs or the data SREs actually going and debugging if something goes wrong, right? And then you see at every edge, you will see an agreement, which is by default. So you don't consume a different product if the agreement is not met. Right. So the same graph that you saw earlier, where there were small nodes and we had a complicated situation because you did not have guarantees. Now what you've done is you've made bigger of those nodes and you've reduced the number of edges. A data model or data product can serve multiple data sets potentially. It doesn't have to serve each table separately, right? And thereby you've reduced the number of edges and the number of nodes in the graph. But then you made sure that each leg serves the reliable downstream product, essentially.
Got it. Yeah. So the reliability, that's a key thing. Yeah.
Reliability is one of the things we talked about, many more non-functional parameters, but right now I'm keeping it to minimum for the sake of simplicity here.
Yes. Yeah, sure.
Right. Even the access methods that you see on top, you could potentially be accessing using apps or SQL or API. So we are basically saying that there is no one method. Whatever method consumer wants is the method.
Yeah, perfect, Rajesh.
Right. This is one more use case. This would probably fall into what I call the inter-domain product, right? How many of you are actually having RevOps product in your enterprise and or you built it in a way?
Yeah, I think most of them would do. Like probably, guys, if you can unmute your line and answer that. RevOps is nothing but taking data from Salesforce and all of that, and then feeding your sales and marketing dashboards and all of it.
Yeah. So fundamentally, a RevOps essentially has your three groups involved or three domains involved. One is your marketing, the other is your sales, and the third is your support. And you're basically picking the domains. What you see, those pink blocks are actually the domain models that I've just put a few, but there could be more from each of these marketing domain or the sales domain or the support domain, right? This could be coming from different source systems. So those are the things until the point you're seeing the pink is not part of the RevOps product, but basically the upstream to the RevOps product. Now, here again, you follow the same pattern where you have the input checker system first. You basically make sure that your models that you're consuming meets your expectation. If it doesn't, you again go back and check, is it a freshness issue? Is it missing data? Can I do anything about it in an automated way? If yes, then I actually do that. If it still doesn't meet the expectation, you basically bail out there, update the alarm, observability, all of that till that point. If it does meet your expectation, the input, then you actually implement the RevOps metrics pipeline. Now, most of the RevOps is all about metrics, right? So you're in this particular case, you have a metrics library that's available to you, and you're actually building the RevOps metrics pipeline. And that output essentially goes back to the virtualized store, which then can be consumed via a user interface that you build specifically for RevOps team. Right now, this could again be built for using the low-code user interface designer or any other library, essentially, right? And then you have those common pieces below where you have the relational engine, you have the product image registries. Whatever product you're building is actually an image in this particular case, and then you have the image deployment environment essentially available to you. So once you build this product and you've tested, you basically use those accelerators to get it quickly deployed on a cloud server or a private cloud server, so on and so forth. Any questions on this? Pretty similar to the previous one. Like I said, once you've started building these accelerators, everything becomes faster. It doesn't have to be a low value product. Even a high value product could be built much faster. Any thoughts so far? Am I missing something on these slides, or anybody believes we can add more?
Yeah, please unmute your line. You have all the permissions to unmute.
Okay, I'm moving further.
Yeah.
So this is the fourth product I took. This is more of, let's say, lightweight machine learning, a recommendation data product, right? And all of us are aware of what a recommendation system does. It's essentially takes the domain information about the users, the products, the activities, their historical purchases, so on and so forth, and then runs a recommendation model to recommend if the consumer, if I can recommend any additional products to this particular specific consumer, right? Now, this is based on various criteria, various tables or models that you have, fundamentally around the consumer, his activities, so on and so forth. Right now, let's look at what would happen if this is the product that you're trying to build. The slide has slightly become bigger, but let me just read it before, and then I think I would request you to look at it closely. But fundamentally, you have the upstream domain models, which is pretty obvious because we're not building from scratch everything. We would pick up the user models, the activity models, and all of that from the upstream. We would store this incoming data schema in a virtualized version store. This is good to have. This is not must have. But suppose you want to go back, audit, so on and so forth, this would be important. Then you would implement the recommender system. I think that there's a typo in that line, but you basically are implementing the recommender system. You store the generated output in the feature store, and then store the model in the virtualized model store, along with the training and the validation data, other artifacts that may be generated as part of the process. And then you use something called an API deployer. This is just another kind of a deployer to launch your recommendation endpoint, which can be consumed via an API. So in this case, you don't have a UI, you're basically publishing it via API, which can then be integrated by the actual system, which is serving the recommendation, right? So let's look at how this is going to actually look. One sec.
Yeah, in the interim, I know it's natural for us to get confused with data products if you're hearing it for the first time, or the concepts may sound familiar.
It's just the same. There's really nothing. Even recommender systems are actually pipelines in many ways. It's just that they are ML pipelines versus the data transformation pipelines that most of the data engineers are familiar with, right? And that's why I'm trying to say that. And if you actually look at the other pieces of it, for instance, we have the input checker system, the automated cleaning system. What can we do about it? All of that is pretty common here too. Then there is something called a metrics library that you see here, even here, right? Because you're actually doing feature engineering. By the way, a lot of feature engineering that happens today for ML systems use SQL in most cases. In many cases where the relational operators are not sufficient, you would probably use some other compute engine. But by and large, in most cases, it just works out, and then you're using the same logic that you're using to build your OLAP models or your metrics, essentially, right? And in the ML world, we call them features, and those features are stored in what we call feature store, which is kind of very similar to metric store, just that in some cases they're materialized views, or in some cases they're materialized tables, so on and so forth, right? So you have basically the data, incoming data, you've got to check the system. Now you do the test train split. You basically do the feature selection, whatever features that you want. Features in this case is nothing but the fields in the tables. You basically compute a bunch of features, which could be similar to computing metrics. And then you're running a bunch of algorithms out there. And then you pick the best algorithm and basically store it in your model catalog. Once you have the model in the catalog, you have this API deployer, which is actually going to publish this new version of the model and actually orchestrate and deploy it on a cloud server. Right? Now, at any point in time, if there is an issue at any stage, again, you collect all the logs as the product engineer wants and push it to the observability platform. Once the model is deployed, you again do the same thing. You publish the details about this particular product to the product marketplace. Again, using a bunch of YAMLs or API interfaces that is available to you. Any thoughts so far?
Nothing. Pretty clear. I think we're coming to the close of the session, Rajesh. But then I
Yeah,
think,
but what I'm saying is these were the 4 products that I wanted to show. Obviously, I've kept it a lot simpler to
and we'll
begin.
share the slides with everyone. So in case you want to pick up those slides, we'll put it on a drive and share it with all of you. So you can use it in your own conversations as well. But one thing I would like to ask you, Rajesh, right? So essentially, what you're saying is the non-functional attributes that we add to existing data projects, not products, are what makes them products today.
So let's go back to this particular use case, for instance.
The reason I asked that, let me give the reasoning also. See, we've invested a lot of effort in building warehouses, like Dinesh said. So we have probably built those marts. The tables are all there. How do we make it a data product from them just being a mark table or a fact table out there? How do I make it a product? See, we can't change everything overnight. See, for somebody starting the data,
I like here what Sanjeev says, and I would probably just point to that. If you want to most simplistically think about a data product, the first thing you have to register in your mind is table is not a product. Okay. So what Sanjeev has actually put it in his, the most simplistic definition that I would put it is a product has three things. One is the data itself, right? Which is your tables and all of that. The second is the domain knowledge or the logic. What you see here, the recommendation pipeline, all of that is the logic, which is specific to this particular domain requirement, right? And then the third is the access interfaces, right? In this particular case, we picked up the API deployer as the access interface. In the previous case, we picked up a user interface as an access. So if you actually want to take away just one piece, the most simple understanding is that the table is just one piece of the product. You have to start putting the domain knowledge part of it. You have to start putting the non-functional attributes that we talked about last time, and then the access method. These are the 4 things. And then, of course, there is a life cycle and all of that, which we haven't covered. But that essentially would make a table feel like a product in a way. Or transition to being looked like a product.
But for new use cases, for new data projects, I can follow a pattern which is completely covering observability, contract validations, and I can build with that in mind because I have a framework available, right? But there's tons of things that are being consumed.
So look, you would not touch. I mean, whatever is working, and the working. But as you actually know, what's actually happening today is a lot of data teams have become support teams, right? And at some point, you will have to realize that the problem only becomes more complex as you add more models, and there are more models dependent on the previous work, so on and so forth, right? So what somebody called spaghetti SQL. I think we are in that churn mode where everything looks like a spaghetti, and you really don't know how to trace back if there is a problem, right? So while we are trying to figure out how do we fix that, or we will have to support it, we will have to start thinking about how do we not repeat it, and that's really where the data products come in. Right now, I just want to leave it because obviously this is not the complete anatomy that I could have spoken. There is a role of access layer. We did not speak a lot about how are we going to use, for instance, in the previous slide, we had the virtualized storage interface, the catalog, all of that, right? What are these interfaces and how are they made available? So that is the first point. What is the role of access layer in general in data product building framework, right? The third point we covered in a way, what are the various ways I can deploy the data products, right? Then what are the various accelerators? For instance, the low code, the declarative language, what is available out there to build the metric layer? What is available to build the input checkers, the cleaners, every single piece that we talked about? What is that we can do to accelerate this development? I mean, the ROI question that was asked earlier would heavily depend on how these frameworks are made available and how they can get used, essentially. Right. Then there is also the app part of it. Like we said, we didn't get into details of, because the apps can be full apps versus micro apps versus stateful versus stateless, right? And essentially, what is you are not going to use one framework for building any kind of app. If you're really looking for a micro app or let's say a small report, you might build it differently than if you're looking for a full application, right? And what is available so that I can actually do that, right? We did not talk about the data products marketplace and the observability piece as an interface we did, but we did not get into the details of how these individual apps themselves would look like, right? But that is fundamentally what we've not covered. Otherwise, I think there's a good amount of takeaway with these slides.
Yeah, thank you. Thanks a lot, Rajesh, for that. Any questions from everyone?
Yeah, Rajesh and Sunil here.
Yeah.
Is there a future session on data marketplace, one which I'm interested in? How does a publicly accessible marketplace work versus an internal organization like internal only marketplace work?
Yeah, I think that's a good point. I don't think we planned anything.
Nothing at the moment, Sunil. So, but then that's also something that is of interest.
I think there are a lot of pieces here which could be of interest if we want to do, for instance, the access layer that we haven't spoken about.
Yeah.
And I've just put it there. Maybe it may not have hit it, but it's a pretty interesting piece if you're really thinking about this problem. Deployability is something that
the access layer could go with the marketplace as well. Like in a marketplace, you would like to sell and buy, and that concept of accessibility comes into picture. Right?
Yeah, so Rajesh, you should also think from the fact that product marketplace people would really want to do a catalog, which is there, and then you solve for access. You need to solve for access governance as part of.
So I will just leave one small piece. The catalogs are the place where you discover data sets today.
I agree.
Marketplace is where you're going to discover finished products, which could be a data set, or could be an API, or could be an app.
Or could be an integration with Excel.
Or could be an app itself. Fundamentally, you're discovering or launching an app, or you're basically discovering the URL for the app or whatever, right? Yeah. So it's a consolidated view of everything that is a product. We do not differentiate by the access method.
Totally.
Any other topics, thoughts, or questions, or suggestions?
Yeah. Good stuff, Rajesh. I just got off a call with a Canadian insurer.
Yeah.
Right? That's why I got delayed. But and we had an interesting conversation about these dashboards and data products. This particular gentleman was responsible for something like 900 dashboards. So it's a complete. It just absorbs everything that he has, right? One challenge that he has is he's unable to create bandwidth to move on. So there is a real migration issue at hand. Even if he wants it, even if he understands clearly, creating the budgets for that is a challenge for him.
Yes.
The second interesting question or idea that he posited was he had this hypothesis that which I disagreed with, that he could go from something like 900 dashboards to something like 10 data products, which he called as the whales. He thinks that this 900 is too finely, the information is presented too finely, and a data product, a much more quote unquote thicker data product will absorb the sprawl that has been caused by the dashboards. That was his second thought. The third thing that he brought up was, let's say we play it out. Let's say we have this new data products infrastructure. By the way, he's clearly distinguishing between a dashboard and a data product. He has an explicit data product manager who systematically builds this out with the full stack, all the different elements that you're talking about. So it's a fairly mature thought process that he has. So the third point that he was saying was, look, if we actually play it out over the next so much time, why would we not end up with 900 data products that we will still have to manage, right? So three things. How do you create bandwidth? Second, is it realistically, is that the kind of inflation that we are talking about, 900 to 10? Is that the degree of inefficiency that is there in the current system? Third, if we play this out, how will it look?
Yeah, I think all valid questions, and I think definitely a longer conversation there. My personal belief on this is that and that is the first piece that we brought in here, which is the domain-oriented data models, right? I think one of the big pieces that we are missing, because we have the star schemas and then we are asking everybody to dip in and create whatever models they want. What happens is a lot of intermediate data sets get created. And there are two flavors that I've seen. One is the intermediate data sets which are simply joined so that the dashboards can be faster. The other is because I do not know why I should change the previous one and what would break, I'm actually just going to create a copy of it and create one more, right? So if you actually get into the details of the 900 dashboards and then underneath the number of tables or the stored procedures that are getting in, you would find that a lot of them are repetitive kind of queries or just queries with minor variations, so on and so forth, right? So I think when you're in the data products world, you don't end up there because you have version management. We talked about the version store all the time so far, right? Unfortunately, in the warehouse world, if you really want to do versioning, you would probably make a copy, if I'm correct, right? There's no other way you could do versioning. Is that true?
Well, I don't know what so they were using Tableau. Definitely they.
So I'm saying Tableau is fine, but see the versioning, the lineage, all of this is not given today, unfortunately, for most organizations. And that's why this sprawl itself is a result of the confusion and the urgency with which I need to deploy. And at that point, because I have blind spots, the easiest thing to do is just create a copy.
Yeah, perfect. Again, just doing a time check. We're 10 minutes over time as usual, 10 or 15 minutes. Any last questions that we have for us? Perfect. Then thank you all for your time today. I have pasted the links of our YouTube and our Slack groups and the LinkedIn pages as well. Please do join us there. Our plan is to do more such sessions. Probably the marketplace could be one, but we are also planning around each of these NFRs, right? Non-functional requirements. How can we deep dive on each one of them? Yeah. How do you build each one of these? Because you can probably do that in your current stack and make it at least look like a data product for your existing projects, which you've already gone live, you've invested a lot of time and effort. But we also then lay the foundation stone around how can you, with the existing investments that you've made, or with very minimal effort, create data products in your own organization. The goal here is to not recreate everything from scratch. The goal that you should carry forward is this is a reference architecture.
I mean, I have a slight opinion, let's say, difference there. We haven't even begun creating products, in my opinion. We haven't created much to say that the consumer has got everything, right? I mean, if you look at any physical world derivative products, take just cereals and you'll find the innumerous products around cereals, right?
Yeah.
And I think that's fundamentally what I want us to focus on, not about what we've done already.
Agree. I think as a start
to really make the consumer feel the value of what a data ecosystem is.
Agree. Again, touching upon that statement, I want to close. But then RevOps is an example, can then be standardized as a data product, but then that data product can be used across hundreds of customers, not just within your organization. See, that's a standardization that we bring on. But then, not to scare you, that's step by step how you start putting your product management skill sets in developing products that are not just reusable internally, but then you're creating a wireframe that can be repeated elsewhere. Right, like how Salesforce created CRM, how, for example, RevOps example comes from Houseware. So Houseware creates a RevOps platform. So I think it's all about that repeatable behavior, but you're within an organization, you're putting the domain ownership, the controls, and building the entire product attributes that can create value for people who are consuming it, as opposed to just creating tables which are not being consumed. I think that's the whole notion, right? I think we're all excited in this journey. Thanks, Rajesh, for your time today. I think it was a great session. And we would see all of you in a very quickly, probably next week or the week after, in another session, deep diving into an NFR of a data product. Right. Thank you all for your time. Thank you. Have a good day, everyone. Thank you. Bye.